So, now we will move to the operation, that is deletion. So, in deletion first we are going to discuss delete the first node. So, we can write like this, delete first node or delete a node from the beginning. So, assume the linked list is like this. So, we have a node like this one, this one. So, assume 3 nodes are there, one is A, another one B, another one is C. So, head is going to refer to this one, and the next this, previous this, and the previous is null, its next is null. Okay. So, now if we want to delete the first node, so initially the structure is like this. If we want to delete the first node, that means delete this one. So, if we delete this one, then head is going to refer to this one, and the previous of this B becomes null, because if you delete this node A, then the previous of this, the previous of the second node will be null. So, if we delete this one, its previous, the previous of the second node B will be null, and head is going to refer to this one. So, simple step. So, we need to write the method like this. So, in the first step, what we are going to do? So, in first step, so check whether the list is empty or not. So, if the list is empty, then we cannot delete the node from empty list. So, in step 1 we can write check for empty list. Then in second step we have to update the head. So, head becomes head dot next, like we have discussed just now. Then what is the next step? So, in next step just update the previous of new head. So, we can write head dot previous equal to null. So, these are the 3 steps we need to follow when we want to delete a node from the beginning, or we can say when we delete the first node. So, if we write the method for this, we can write like this one. So, we can write public void and assume the name of the method is delete first, and here no parameter is required, we want to delete the first node. So, for check empty list we can write a if condition. So, if head equal to null, so it is double equal to, if head equal to null, so we can write system dot out dot println. In short I am writing SOP empty list. Now, in the else part, that means when the list is not empty, so we can write in the else part head equal to head dot next, like here we have written update the head. So, head equal to head dot next, then update the previous of the new head. So, like this we have written, we can write head dot previous equal to null, then this end of else, end of method. So, this is the method we need to write if we want to delete a node from the beginning. So, now we will discuss how to delete the last node of a double linked list. So, assume the list is given like this. So, assume it is A, it is B, it is C, it is D, and the next and previous are like this, null, it is null, and head is referring to this one, and here the method name is delete last, or the operation is delete last. So, here we want to delete the last node of this double linked list, that means delete the node D. So, if we want to delete this node D, we can just make this next of C will null. So, if we make this next of C is null, then the node D is automatically deleted, or we cannot reach this D. So, just update the next and remove this one. So, in place of referring to the next to D, just make next to null. So, how to do this? So, for this you can find the tail node or the last node, and after getting the last node just make the next of its predecessor to null. That means just make the next of C to null, or you can say just make the previous node next of the last node to null. So, here how to find the last node? So, you can traverse from the list from the beginning, or you can take another reference like we have discussed, tail node, that is going to identify the tail node always. So, we can traverse the list like we have discussed earlier and find the last node. So, for that we can write the steps. So, what is the step 1? So, the step 1 is, or first step is, take a reference variable, assume current, that points to the first node, that refers or that points to the first node, or you can say head. So, head refers to the first node. So, head of the list. Then what is the next step? So, in next step we can write like this, move this current so that it now points to the last node of the list. So, move current so that it points to the last node of the list. Then what is the next step? So, in next step just store null in the next field of its preceding node. So, the steps 1 and 2 are just to find the last node. So, once we find the last node, then store null in the next field of the preceding node. So, these 3 steps we can write in a method. So, assume the method name is delete last. So, we can write like this. So, public void delete last. Here also no parameter is required. Now, first we check whether the list is empty or not. So, for that we can write if head equal to null, then system.out.println, in short I am writing SOP, empty list we can write. Okay. Now, if the list is not empty, that means in the else part we can write, we can take one reference variable current, and initially it is going to refer to head, or it is going to refer to the first node. So, while you implement, we can write node current, because we are not writing the type of current. Generally in algorithm we do not write. Okay. So, anyway you can write node current equal to head. Then we can use a loop like this, while current dot next not equal to null, then update the value of current, that means current equal to current dot next. So, now after the loop, so when the loop terminates, the value of current becomes the last node. So, when the loop terminates, the value of current will be the last node. So, here you can observe. So, when the loop terminates, the value of current is this one, the last node. So, we want to make the next of C to null. So how to find the next of C? So the previous of current is C and its next is null. So we can write this one. We want to make the next of previous of current. So for that we can write current dot previous, that means last node's previous, and its next. So current dot previous is next. So we can write current dot previous dot next equal to null. So this end of else, end of method. So this is the method for deleting last node from a double linked list. So if you understood this one, please write understood in the comment section. So these are the steps. So these two steps are used to find the last node, and in step 3 we are just updating the next of the predecessor. Now we are going to discuss the method that is delete from any position. So another type of deletion. So here we can observe that is case 3. In deletion we have discussed 2 cases of deletion. Now it is case 3. So in case 3 we are going to delete from any position. So for simplicity we are considering that we want to delete a node where the key value is given or where the data is given here in this example. So consider the list is like this. So okay, so here you can observe, assume its data is A, B, C, then D, then E. So here next of E is null, and here the previous of A is null, and head is referring to this one. So this is the initial structure. Now we want to delete this one, this node C from the list. That means we want to delete this one. So we want to delete this node C from the list, or if we want to delete a node that contains the value C in the list. So then what we have to do? Take a reference variable current and start from the beginning and reach the node that we want to delete. So here we can say current is referring to this one. Current is a reference variable that refers to the node which we want to delete. So if we delete this one, if we delete this node, then the next of B, that means this one, the next of B is going to refer to D directly. So let me draw the figure like this. The next of B is going to refer to D. Similarly, the previous of D is going to refer to B directly. The previous of D is going to refer B. So if we update this one, then automatically we can say the node is deleted. So we need to update just the next of its predecessor and the previous of its successor for the deletion. So what are the steps we need to follow? So in step 1 we can write like this. What is the first step? So in first step, or here we can write, in step 1 take a reference, reference variable current, and make it point to the first node of the list, and make it point to the first node of the list. Then what is the next step? So in next step, move the current so that its data part is equal to the value or key that we want to delete. So move current, so that its data part is equal to the value or key that we want to delete. So, to the value or key, simply I am writing. Now, what is the next step? So, in next step we can write the link before the one that we want to delete is set to point to the current dot next. So, we can write like this: the next field of current dot previous. So, current refers to the node that we want to delete. So, the next field of current dot previous is set to refer to the current dot next. And what is the next step? So, in next step the previous field of current dot next is set to point or set to refer to current dot previous. So, first find the node that we want to delete and current refers to that node. Now, update the next of its predecessor node, so that it is going to refer to the next of current. Similarly, update the previous of its next node, so that it is going to refer to the previous of current. So, these things we have written in step 3 and step 4. So, we can write a method for this, or using these steps we can write a method that will be more clear. So, public void, assume the name of the method is delete key, and here we are taking one character value, that is key. So, here we can write if head equal to null. So, like the previous deletion cases, we need to check whether the list is empty or not. So, if head is null, we can write empty list. Else, so in the else part we can write node current equal to head, then we move until we find the key value that we want to delete. So, while current dot data not equal to key, so we can write current equal to current dot next. Now, when the loop terminates, the value of current refers to the node that we want to delete. So, here we find the node that we want to delete and current refers to this one. So, now update its next. So, which next? The previous of currents next. So, for that we can write current dot previous. So, the node just before the current and its next. So, the previous node's next. So, for that we can write next. So, it is going to refer to this one. So, its next, this one, its next value is going to refer to this one. So, we find the next, that means current dot prev dot next means this one. So, it is going to refer to D. So, D means current dot next. So, current is referring to C. So, current dot next means D. So, for that we can write current dot prev dot next equal to, we can write current dot next. Now we will update its previous. So its previous we want to update. So which node's previous? Current dot next previous. So D is previous. D means current dot next. Current dot next dot previous. It should refer to B. B means current dot previous. So this thing we can write which previous? Now current dot next dot previous. That means the previous of the next node of current. So current dot next, that means the next node of current and its previous. So its previous is going to refer to current dot previous. Current dot previous. So these are the two steps only to update the previous and next. Then this is end of else and end of method. So this is the method to remove a key from the linked list. So if you understood this one, please write understood in the comment. So if you understood this method, that means delete a key. So if you understood this one, so you can write the method to delete a node at a given position. So here key value is given. So in place of the key value, if we give, suppose delete the node that is at position 3 or delete the node that is at position 4, so you can simply delete that one. So this is all about the 3 cases of deletion, like delete first, delete last and delete at any position or delete a key value. We have discussed the concept of double linked list. We have also discussed the concept of single linked list. Now we are going to discuss some limitations of this linked list structure. So the first limitation is space, that is to manage the links. That means here for single linked list we have one link that is next, and for double linked list we need 2 links or 2 references, one is next, another one is previous. So to manage these links or to manage these references, we need some extra space in memory. So in addition to the data, we need some space for managing the references or links. So extra space is required in linked list. Now another limitation we can consider. So the linked list structure is not suitable for random access. So to access one node, we have to start from the head and we move either in the forward direction or in the backward direction to reach the node. So if we start from head, generally we have to follow the forward direction. Otherwise in double linked list we can start from any node and we can move either forward or backward direction, but we cannot randomly access a node like array. So in array, if we know the starting address of the array, we can easily access the other elements. So here this linked list structure is not suitable for random access. So you can consider these are the basic 2 limitations of linked list. Now we will write the complete program that implements the methods that we have discussed for double linked list. So first we define a node class like we have earlier discussed. So we can write the class node like we have already discussed, and in the class node we have one character value data. So char data and node next, node previous, then the constructor node char data, and here we can write this dot data equal to data, then this dot next equal to null, this dot previous equal to null. So end of constructor, end of class. So This is all about class node. We have discussed this earlier. Now we will write another class and assume the class name is linked list. So we can write class and the name of the class is assume linked list. And here in the linked list class we have one attribute head that is of type node. So here we will first write the method for add first. So like we have already discussed the method. So public void add first, and here we will take one character. And so like we have discussed, we need to create the newest node first. So node newest equal to new node and pass the data, then update the next of newest. So newest dot next equal to head. So we are writing the same steps that already discussed. So if head not equal to null, that means the list is not empty, then head dot previous equal to newest, then we can write head equal to newest. So this statement updates the head. So end of method. Now we will write the method to insert at the last. So this is the method for inserting at first, this one. Now we will write the method that is going to insert at last. So here we can just write the same thing that we have discussed earlier. So public void method name is add last, and here it is going to take one character value data. Now similar to the previous one, create the new node. So node newest equal to new node and pass the data here. Then if head equal to null, that means the list is empty, then head equal to newest, else that means the list is not empty, then we can take a reference variable current, and initially it is assigned to the first node or head. Then we can use a loop. So while current dot next not equal to null, current equal to current dot next, then when the loop terminates, the value of current denotes the tail node. So for that we can write node tail equal to current. So when the loop terminates, the current refers to the tail node. That's why we are writing node tail equal to current after the loop. So now we'll write newest dot previous equal to tail and tail dot next equal to newest. So here we are not taking a reference variable tail that is going to refer always the tail node. That's why we are not updating the tail node after inserting a node at the last. So we are taking one reference variable current and traversing through the list to find the tail node. Like the head, we are not taking one extra reference variable to denote the tail node. That's why we are not updating the tail node here at the end after insertion. Okay, so now we will write another method that we have already discussed, that is add any, that means add in the middle or add at any position. So for that we can write public void add any. So similar, it is exactly same as the method we have already discussed. Int position and character data. Now create the new node. So node newest equal to new node and pass the data. Then take the reference current, and initially current refers to head. Now use a loop. So for int I equal to 0, I less than position -1, I plus plus. Then inside this loop we write current equal to current dot next. Then we can write after the loop newest dot next equal to current dot next, current dot next. So these are the steps that we have already discussed. We are writing the exact statements. So current dot next equal to current dot next dot previous, current dot next dot previous equal to newest, then newest dot previous equal to current, then current dot next equal to newest. So these are the steps we have already discussed. Now we are going to write another method, that is to traverse the linked list or to display the elements of the linked list. So for that, here I am writing, assume the name of the method is display. So void display. So it is not taking any parameter. Now here we are taking a temporary reference current, and initially current refers to head. Now we can write if head equal to null, then system.out.println. In short, I am writing SOP, list is empty, or we can write empty list, empty list. Then in the else part we can write, that means if the list is not empty we can use a loop. So while current not equal to null, it is similar to the traversing of single linked list. So inside the loop we will just print system.out.print current.data, current.data, then add some space. Then we can write current equal to current dot next, that means current moves to the next node. So this is end of loop, end of else, then end of method. Now we'll write the method delete. So we have already discussed about the delete method. So we can write this one, public void, then delete first. That means when we want to delete the first node. Okay. So if head is null, if head equal to null, we can print the list is empty, or simply we can print empty list. Else, that means when the list is not empty. So in the else part, just update the head, that means head is going to refer to the next node. So head becomes head dot next, and head dot previous becomes null. End of else, end of method. So this is delete first method. Now we will write the method, that is delete last. So we have already discussed the same thing we are writing here, public void delete last. So here we are writing the same thing, whether the list is empty or not. So if head equal to null, simply print system.out.println. In short, I am writing s.over.p. So we can write empty list. Now if the list is not empty, that means in the else part we can write node current equal to head and traverse through the link to find the tail node. So while current dot next not equal to null. So the same steps we are writing that already discussed. Current equal to current dot next. Now the current, so when the loop terminates, the current refers to the last node. So after the loop we can write current dot previous dot next equal to null, then end of else, end of method. Now we will write another method, that is delete a key. So following the same steps that we have already discussed, or we are rewriting the same method. So public void, assume the name of the method is delete key and it is taking one character value and assume the character is key. Now we are going to check whether the list is empty or not. So if head is null, then we can print empty list. Now in the else part we are going to write, that means when the list is not empty, so we can take a reference current. So node current equal to head, then while current dot data not equal to key, current dot data not equal to key, current equal to current dot next, current equal to current dot next. That means find the node that we want to delete using this loop. Now we will write this one, current dot previous dot next equal to current dot next. So it is exactly same statement that we have discussed. Now another statement, current dot next dot previous equal to current dot previous. Now end of this loop, sorry, end of else, this one is end of else, end of method and end of class linked list. Now we will write another class where we are going to write the main method. So for that we can write a class, assume the name of the class is test, assume name is test. So in the test class we can write the main method. So for that we can write public static void main, and here we can write string array args. Now we can create one object of linked list. So we can write like this, linked list, assume the name of the list is my list or name of the object is my list. So we can write linked list my list equal to new linked list. Now we can call the methods using this object myList, or we can call the methods on the object myList. So here we can call the method like myList dot add fast, and here we can pass one character a. Similarly, we can write myList dot add fast, we can pass another value b. Similarly, we can write myList dot add last, suppose we can pass c. Similarly, we can write myList dot add last, we can pass d. Now we can call the add any method. So myList dot add any, suppose the position is 2 and here we want to insert p. Similarly, we can again call the add any method, and at the same position 2 we want to insert suppose q. Now we can call the display method. So myList dot display, so it is going to print the elements of the myList. Now we can write system.out.println to add some space. Again we can write system.out.println to add a new line or to add some space. Now we can call the delete method like this. We can write myList dot delete fast. Similarly, we can write myList dot delete last. Now we can write, or here we can again call myList dot display to display the elements after deleting the first and deleting the last. Now we can write myList dot delete key method, delete key, and assume we want to delete suppose c or p we want to delete. So delete key p. Then we can again call myList dot display to check whether p is deleted or not. Now end of this main method, end of this class. So when we write myList add first, so in the list a is inserted, then myList add first b, so b is inserted, then after b a is there, so add last c, so the structure of this linked list becomes bac, then add last d, so like this bacd, then myList add any at position 2p, so this is position 0, position 0, position 1, position 2. So here in place of c, p is going to be inserted, so here the structure will be b, a, then p, then c, then d. Now again at position 2 q is going to be inserted, so the structure like b, a, q, p, c, then d. So myList dot display, so it is going to display in this way baq, p, c, d, then print, so some space are going to be printed. Then myList dot delete first, that means this one is going to be deleted, so the new list becomes a, q, p, c, d, so a, q, p, c, d. Then myList dot delete last, so when we call this delete last, so the last node is deleted, so a, q, p, c. Now myList dot display, so this one a, q, p, c is going to be displayed. Then myList dot delete key p, that means this node is going to be deleted, so the structure becomes a, q, c. Then myList dot display, so it is going to display a, q, c. So this is all about the implementation of double linked list. So first here we are creating a node, and in the class linked list we are writing all the methods add first, add last, add any, then display, then delete first, delete last, delete key, then we are writing another class test, there we are writing the main method and creating one object of my list, one object of linked list, that is my list. Then we are invoking the add first method, add last method, add any method, display method, then delete first method, delete last method, then display method, delete key method, then display method. So this is all about the implementation of double linked list. So if you understood this concept, so please write understood in the comment section.